All right, so as a brief recap, because I forgot, Doom, WAD, where's all the data? Adventure, 5 letters, 3 letters for extension. This would have been funnier if you were here, and if you're only watching this now, you should have been in class. Shame on you. So we need to read from text files. It's actually very helpful to be able to read from text files or read from sources other than the console. And the first place we're going to look is text files. And it's way different, okay? It's probably way different than things you've done in the past, unless you have done more beyond the current coursework here, because everything is done through a stream. So we need to talk about these classes, stream readers and stream writers, in order to deal with that. But now that I think about it, I'm doing these lectures out of order. So I'm going to have to postpone that homework. You keep doing that, and I do not think it means what you think it means. This is not a good thing for you, because it means I'll have to give you double homework next time. All right, so what we're actually going to do is talk about more types of errors, and that's okay. Yeah, exception handling first. Okay. All right, so preview of coming attractions, we're going to have to deal with files, but today, exception handling. We know that if you try to parse an int and you type in Bob, the program throws up all over your face, right? Yes, okay, that's the thing. That's why we, instead of using int.parse, we use try parse. But why would you put a function or a method into a framework if it's really only ever going to blow stuff up? Well, because we have these things called exceptions. We're going to talk about how to handle exceptions. Everybody's my favorite word, the paradigm of exceptions in object-oriented programming. Okay, so .NET is a framework. It's all the functions and classes and methods that are part of it. And it's part of an object-oriented programming model, meaning that we treat it so that every object knows about itself. Array knows its count. Excuse me, array knows its length. List knows its count. We can add things. We can use verbs on a object, which is itself a noun. But weird things can still happen. Bad things can happen. And rather than exhaustively checking for every kind of problem, we will typically write exception handlers. We will say, hey, some bad stuff might happen. If bad things occur in this section, well, maybe we can ignore it. Maybe we can recover from it. It makes it so that you write the logical flow of your code, and then you just put a little bit around it to handle bad things that might pop up. He's not having a good day. So we introduced 2 new keywords in C#, try and catch. Okay? Try says, hey, try to do this. And if everything goes according to plan, well, try doesn't really do anything. Catch is what happens when something bad happens. When something bad happens while you're trying something, it will skip to the catch block. So instead of blowing up and throwing an error onto the console, it will go to this catch block, and maybe you'll be able to recover from it. We can actually have multiple catches, so we can try something and then catch certain types of problems and then catch other types of problems, and on and on. So here's an example. Int.parse, okay? We have 2 ways of having an error with an int.parse. In fact, when we did int.parse many moons ago, I actually typed in a very long number, and the program blew up. I also typed in Bob, and the program blew up. What we didn't really focus on is how did it blow up. It failed in different and unique and interesting ways. When I typed in Bob, it actually threw a format exception, And that's sort of the way we talk about exceptions. They are thrown, at least in C#. If you're in Python, they're raised. Although I tend to think of throwing more as a sort of horizontal action, raising. I digress. So these two catch blocks will run conditionally, meaning they won't always run. They'll run only if something happens. In this case, if int.parse or console.writeLine, if either of those causes a format exception to be thrown, we'll print out invalid integer number. If, however, the number that we parse is too big, the last catch block will be engaged. So not both of them, one or the other. Oh, this mouse doesn't work, which is why nothing is happening. So let's just look at how that works. Without try-catch, we saw that things just kind of exploded. All right. So if we, for a moment, ignore all the try-catch stuff, all we're doing is read line, parse, print out the number. This is actually old code. Nothing is new here. If I run this, and if I run the correct one, I can already see it. Handling exceptions, start. And that's not going to work either because I hit debug, not start debugging. Now it's running. Okay. So if I type 5, prints you entered a valid number 5. Like most integers, this will be fine. If I type a large number, have to be careful I didn't hit any letters in there. That is bigger than an integer. What's the largest value that can be in an integer? 7? What's the first digit? 1, 2. 2. I think 2 billion and change, 2.4 billion and change. This is slightly larger than 2 billion. But isn't that a great little error message? How would you actually code that up? You'd have to write code to parse a very long string, see if the first digit was more than 2, and then it was longer than 6 characters or something. In this case, we let the error just get thrown. It's thrown at us, and we catch the error, and we say, hey, this is too big. So try.parse, or rather int.parse, fails in a helpful way. We typically think of errors as unhelpful, but the way in which something fails can be a diagnostic criteria. So here we're catching an overflow exception. If, however, I type Bob, it's an invalid integer number, also not a correct spelling. How do you spell it, Dave? All right, we don't have enough time in class for that. Okay, back to the slides. So exceptions are as simple as encasing code that could cause problems in a try block, and then providing one or more catch blocks. We're going to go back to this error before too long. But an exception, just like an int, is an object. Everything in C# is an object. So the type of object is called an exception. In this case, it's system.exception, just like an int is really a system.int32. Everything is part of the system namespace. And as an object, it has fields and properties. Things like the message, a stack trace, which this is like going back what called what, which caused your program to fail. So main called int.parse maybe called something else, lets you track down exactly where the error occurred on what line. And an inner exception. So sometimes, for example, in our code here, we caught a format exception. We said, okay, this is an invalid integer number. In this case, we just leave after that. We just, okay, fine, we caught it and we continue on. No errors occur. But oftentimes what you'll try to do is you'll try to catch an error, try to recover, and be unable to recover. In that case, you will throw the exception to somebody else. And this is why in Python they call it raise. When you raise an exception, you send it to the function that called you. You go, here you go. I don't want to deal with you. You deal with it. And then they can try to deal with it. And then they might raise it. And what happens if main raises an exception? Where does it go from main? To the console. Well, sort of. Well, it doesn't. That's where the things get printed. Where it goes is to the OS. It basically says, nope, I got nothing. And the OS says, okay, we're going to shut you down. You're misbehaving. Okay. But yeah, all of those are about right. It dies. Go ahead.
How do you determine what exceptions you want to use?
You look at what could go wrong. I'm going to let you rephrase that. Just think on that for a second. Keeping on. So this example here purposefully causes an exception. Don't keep playing with it till it blows up. That's not acceptable. This is a slightly different example, though, because now what I'm trying to do is I'm trying to look at the properties of an exception. So in the previous example, I say catch overflow exception, catch format exception. But I'm not doing anything with that exception. I'm just printing something out and moving on with my day. In real life, you really want to do more. So the exception that you catch can be used as an argument. So here, I catch a format exception, and inside the catch block, I can reference that exception. I can say, hey, FE, what is your message? What is your stack trace? Do you have an inner exception? So here we can say, oh, we caught this exception, we get the message, and print it out. And this is what we get, okay? So our message is input string was not in a correct format. That's what a format exception does. That's its default message. When you create a format exception, that's the message. The stack trace is unique to the program you're writing. So how did we run this program? Main started, then we called cause format exception, then we called int32.parse. And that's where the exception occurred. Well, not quite. If you read from the bottom up, at main, line 15, we called cause format exception on line 8, which then called parse. Parse then called parse int32 with a couple of other default values, number styles and format info. And that's when the exception was actually thrown. So we can trace all the way through that to find where the error was caused. File names, bugs, okay. Yeah. Almost always you're running in debug mode in the class. Yes. Well, yeah, we just duplicated that. If you didn't catch it, it would raise that error, and raising that to the last level prints out the error and the stack trace. FE would be an instance of format exception. That's exactly the right terminology. Okay. Format exception. is an instance. Yes. Okay. Let's just actually pause in the middle of that demo, because I want to show you what else is part of an exception. So let's put a breakpoint on the exception handler. Here it is inside of the catch block. Debug. So this takes a second to actually get here, because exceptions do take a little more time. If I look at FE, FE has a lot of properties internal to it. You may not be able to see everything there, but we have things like an inner exception, a message, a source. The stack trace is itself a string. Okay, so this is the stack trace, which is exactly what you'd expect. This called this, called this, called this. In this case, our inner exception is null. Inner exception is itself an exception. Okay. And when we actually finish running it, this does things two different ways. If you just print FE all by itself, this is the output. This is what happens when you don't catch an exception. It will just print FE. It'll print the exception. That's exception caught, system format exception, input string not in the correct format, and the stack trace. But those can be broken down. There's a message, a stack trace. Those are separate properties of an exception. The message, it's just that part. Input string was not in the correct format. Oftentimes, as a programmer, it is your job to catch these low-level exceptions and produce exceptions that are more usable for other people. Okay, so maybe you get a format exception and you raise a new kind of exception, something that has a message that is more descriptive. Okay, so far we've talked about try and catch. We can catch multiple types of exceptions in one group. Yes? Yeah, you can catch any exception type. Even if you make your own exception type, you can catch that. Okay? And we've talked about the fact that exceptions have properties that you can and should use. Okay. Now, you just asked, can I make my own exceptions or can I catch my own exceptions? Of course, but exceptions are objects. And we haven't talked a lot about inheritance. That's more of a little bit later on topic. But you should know that everything that we talk about when we're talking about exceptions really is a type of exception. Now, that doesn't make sense on the surface. Every exception is an exception. What I mean is an overflow exception can be thought of as an exception. Now, overflow exception is all down here. Now, both divide by zero exceptions, which happens if you divide by zero, and overflow exceptions, which happen if you try to make a number too large, those are both what we call arithmetic exceptions. All three of those are classes. There is a class called arithmetic exception. There's a class called divide by zero exception. But through this sort of family tree, everything ends up being an exception. When we catch exceptions, not only do we catch what we ask for, so say we wanted to catch arithmetic exception, we will catch all things that are thrown as arithmetic exceptions, but we will also catch anything lower in this hierarchy. So if I said catch any system exception, if a format exception happens, I get that. If an arithmetic exception happens, I would still go to that same catch block. And that's why, if I go back to the first demo, there was a part commented out. here, catch exception. Well, it's perfectly valid to catch an exception. C#, the Visual Studio compiler, has actually gotten smart enough to not even let me compile this. Okay, I don't think I can run it. It's not a polite warning. Yeah, it doesn't even bother trying to run it. It ran the previous code. If I hover on this, it actually tells me exactly what the problem is. An exception that is thrown, a previous catch clause already catches all exceptions of this type, or of a super type of this class. It even tells me exception is a super type. This is what it's talking about. It's talking about this hierarchy. Okay. Format exceptions, integer overflow exceptions, they are all exceptions. Yes? No, it catches in order. So this won't fly, but if I took this, there we go, and put it down here, that would be okay. Okay? Because it's going to check in order. So it's going to first check for format exceptions. Then it's going to check for overflow exceptions. And then it will check for any other kind of exception. So we have to add on to our previous understanding of catch. If you have multiple catch blocks, they're checked in the order you write them. So the order matters. They also correspond to the hierarchy. So format exception, I need to stop trying to use that mouse. If I right-click on format exception and say go to definition, it's going to open up some sample file. But you can see that format exception has system exception next to it. That means it's inheriting from system exception. If I go to the definition of an overflow exception, it's of type arithmetic exception. So we have an arithmetic exception. They're both arithmetic expressions. Arithmetic exceptions. So it's not shown on this hierarchy, but this is just a subset of all exceptions. There's plenty of exceptions to go around, but they're all arithmetic exceptions. So if I were to put up here catch arithmetic exception, I only get a squiggly on overflow exception, because format exception, go to definition, is a system exception. So it's not in that part of the hierarchy. Yes? Mine? Wherever I put them. So I can make exceptions of myself. And we haven't talked about how to make our own classes yet. So don't think you need to know how to do this yet. But I could put it so that it inherits from exception, or from application exception, or from invalid student exception, which is a fake one. Generally, we don't inherit from anything on the left side of here. Everything that we make should be probably inheriting from application exception, because we're writing an application. System exceptions are things that happen in the system. So most times, if you're going to just catch an error and not really handle it, you're just converting from a system exception type into some other kind of application. So, for example, this invalid student exception. This could be as simple as trying to parse a student ID, and if there's a Bob inside of the student number, you throw an invalid student ID. That makes sense. A student ID is all numbers, right? Okay, if your student ID is all numbers and you see a letter in it, that's an invalid student ID exception. It's more useful to the person who's coding using your class to see invalid student than to see invalid format exception. There we go. But what you would do, because we do have properties of an exception. There's one property called inner exception. So you would create an invalid student exception. And the inner class, or the inner exception, you would assign that to the format exception that was thrown. And that way, if a programmer was looking at this, they could say, oh, invalid student, okay, I know about where I'm creating a student, so I'll go there. Or they could look even deeper to the inner exception. And you can nest these exceptions forever, basically, within the limits of memory. Okay? As you said, where do things fall if you're creating your own? Inside of or under application exception. And we did talk about this. Arithmetic exception will catch anything that inherits from arithmetic exception. Yes?
So assuming that your exception is successfully handling errors, does the program control just catch that exception?
It does. With one exception called a finally block, which we haven't talked about yet. So this won't even compile. This is an older code example. We just did this in the example code. You cannot put exception up top. It won't compile. Because if you catch an exception, then nothing else can be caught because everything inherits from exception. So in the order, you would go from most specific to most generic. Adam? You would put the most generic, which encompasses all of the things. The highest in the hierarchy should go at the bottom. No, you would take that catch block from catch exception, open squiggly, to the close squiggly. No. So okay, back up a second. Where do we put try-catch blocks? Anywhere you might get an exception. So int.parse will absolutely throw exceptions. If you put bad data in, you get an exception. Keep calling int.parse? Well, if you do it in a loop, I would put the try-catch block in a loop. If you have a bunch of calls to try parse, it depends, right? So maybe you can put the try-catch block around anything inside of a function. You can put it around your entire program. Your code won't be very good, because there is a performance hit when you use exceptions. So you want them for unexpected things. 99 times out of 100, people will generally put good input in. It's the 1% of the time that they put bad input in that exceptions are going to occur. Okay, and that's where you can take the performance hit to hopefully recover. So you want to put a try block, forget the catch blocks for a second, try block around the smallest part of your code that you can that will rely on the data. For example, if we go back a couple of examples. Oh, yeah, the catch comes right after the closed squiggly of the try. You could put that all inside of one try block. Right. So, oh no, not this one, one more. This one here. Notice that there are 2 lines in the try block. Okay. The reason there are 2 lines in the try block is because the second line won't work if int.parse throws an exception. Because the way this is going to work, first line is console.readline. Okay, S contains a string now. Then we call parse. Parse throws an exception because Ben typed in Bob. And what's the next line that executes? If string S is Bob, and we execute int.parse, what should the next line be? Which console.writeline? There's 3. Which catch block? That's what I'm asking. If I type in Bob, there is no invalid integer. Oh, the string invalid integer. The format exception catch block will execute. Okay. So we skip over write line. If we had only done it around the parse, because console.writeline isn't going to throw that kind of an exception, right? We could have put that after the catch block. But Oh, it's being cute. Like we didn't actually assign it to an integer. But if we had tried to assign it to an integer, that integer wouldn't have a valid value because parse never returned. It threw up on you. We printed out invalid integer, and then our number would have no valid value. So we can't console.writeLine the value if we haven't parsed it. So that is the critical block. Okay. So you can catch everything. You can catch all of the exceptions just by saying catch. But that's not really helpful to you in recovering because you don't know what kind of exception occurred. But everything does inherit from system.exception. So if you try to catch an exception and you don't know what's going to be there, you can catch that and it will catch everything. And maybe you do that as a debugging tool. I'm going to catch everything and see what weird errors pop up. Okay? Yes?
When the errors do pop up in just a normal catch like that, will it tell you what exception is thrown?
So, after a fashion. In C#, there's something called reflection where you can look back on an object and determine its type. So if you're debugging, yeah, you can get into that information. But all you're going to get are the properties of exception, which in this case are message and stack trace. So the message will certainly be helpful, but you won't be able to quite so easily just grab the type. Yes? It all depends on what happens in the catch block, right? If the catch block itself throws an error, then no, it'll throw up to the next calling function. If it recovers, then yeah, it'll keep going. How do you throw exceptions? You use the keyword throw. That's it, really. But you need to throw an object. So you need to create an exception object. How do you usually create an object? What keyword do you use to create objects? Int? New. That's a better answer than int. Yeah. So when we throw our method, or throw our exceptions, if you think about a program, here's a standard for the operating system. It's the common language runtime. It calls main calls the first function. The first function calls the second function. Second function calls the third function, and that's where an exception gets thrown. At that point, you'll see if there's a catch block inside that third function. If there is, it'll go to that catch block. If that catch block does not recover correctly, or if there is no catch block, it goes up one method to method 2, sees if it has a catch block. Maybe it does, maybe it doesn't. If it doesn't, goes up another method and another method until it gets all the way to main. And if there's nothing in main, then it goes back to the common language runtime, the .NET framework, and it launches an error at you. If you're in a console window, it prints it to the console. If you're in a Windows environment, it prints it in a little dialog box. So we can throw exceptions with the throw keyword, and we create a new argument. So this is creating an argument exception, which is a little bit more descriptive. Okay. In this case, the first example right at the top just sets the message. So say we're trying to parse an integer and it's part of some larger program. We can throw an argument exception, meaning whatever you gave to us was bad, an argument exception, and the message is invalid amount. It doesn't matter if the invalid amount was Bob or -5 or 0 or some other value. What matters is that the argument was the problem. In the second example, the more full-featured example, we catch the format exception FE. This is where we get into inner exceptions. So not only do we create an argument exception, but inside of that argument exception, you can think of it as a disciplinary file, right? So inside this disciplinary file, oh, here's the list of problems. It's an invalid number. Oh, what do we have here? This invalid number was caused by a format exception. Oh, what about what's going on with this format exception? Oh, it has a stack trace. The stack trace for this format exception started on the line int.parse. Okay? So when you create a new exception, that exception starts right there. Okay? On that line. So the stack traces aren't necessarily helpful. Okay? If you don't include the inner exception, you lose all of that information. You lose all of the stack information before that happened. Okay? And this is commonly what you'll do. It's not really about recovering from the error. It's about translating it into something a little bit more useful. Here's another example where maybe you tried to recover from it, or maybe you just needed to do something because you saw that it happened, but you know you have no hope of recovering from this. So you make a little note to the user, oh, parse failed, and you throw the exception again. This is the equivalent of computer science hot potato. Throw, oh, I don't want this. Throw it to the next person. Okay? And there's two ways of doing that. Either you use the argument version where you actually catch a variable fe, or you can just say throw. Yes. Once you throw fe, well, if we go back here, so say that was method n. Okay, method n, that's where the problem occurred, and we caught it in method n. Then we threw it again. So then it's going to go to method 2, and method 2 is going to have a chance to save it. Okay, so it's kind of like you looked at it, you said, yeah, no, this is a problem for future Ben. Yes, that's exactly it. Okay, or down, depending on if you're standing on your head. Okay, so fairly common function, square root. Well, you can't take the square root of a negative number though, because there is no number that you can square to equal a negative number. That's math. I lied. There is no real number that you can square to make -1. That's math, or maths, depending on. So what do we say here? We say if the value is less than 1, we throw another exception. I am not going to require you to exhaustively memorize every type of exception under the planet. In fact, this hierarchy that we had back here, that's one of the best hierarchies I've ever seen. And I've looked because I thought it would be nice to like give you guys a sheet of like, look, this is the hierarchy of exceptions. It's not really a thing, okay? And nor should it be, because there are tons of exceptions. The framework is a living organism. It moves around. These are pretty much major ones. And then beyond those, it sort of depends on what domain you're programming in. Okay, so what do? We just throw an exception. We don't want to deal with this type of argument, this less than 0 argument. So we throw an exception, and as long as we don't throw that exception, then we return the square root. Okay? So how do you choose what kind of exception to throw? Well, you kind of browse. You look through what you have. There are argument exceptions, several of them. Argument exception is sort of a top-level one. Then you can have an argument is null, an argument's out of range. You've seen me throw exceptions in your sample projects. I throw a not implemented exception. That's descriptive. You haven't implemented the function I asked you to. Or you can create your own when we finally talk about that. Finally, before you leave, I want to talk about the finally block. Okay. When you try something, there might be a catch block that occurs, but you can also have something called a finally block. The finally block will run whether or not an exception occurs. Even if an exception does occur, even if you throw an exception inside of that, finally will always run. I just want to show you this demo because it blew my mind, and it does take a few attempts to look at before you really decide that it's quite worthwhile. Try finally. So, and this might be slightly different than the example on the M drive because I've added a few things. So I've got some lines here listed. 5 lines. 1, 2, 3, 3A and 3B, 4, and 5. Now, what will cause this program to throw an exception?
When the string str is not an integer.
Right. If I typed in Bob, it would be bad. So if I run this and I type in 5, it goes 1, 2, 3A, 4. And that should make sense. It's in order. It prints out 1, 2, 3A, and then finally it prints 4, and then not 5. Oh, so the return, this is the part that gets a little confusing. It does not print line 5. Why? Because the return is up here. So it printed 1, 2, 3 and said return. Normally that would go back to the calling function, but the finally executes anyway. That's an important feature. I'm going to run it one more time and put in Bob. This time, the 5th line does execute after the finally because it runs 3B. 3B is inside of the catch block. So we've skipped over the console.write line, skipped over the return, and gone to the catch block. Once we're done with the catch block, regardless of whether the catch was thrown or not, we go to the finally block. That's line 4. And now we leave the finally block and go to line 5. So it's actually harder to follow when we have a successful parse than it is for an unsuccessful parse. Let's look at the two of them together. Oh my gosh, save me from trackpads. Okay. So, I have 2 failed parsings. So I was trying to do, no, bad, and then good. Okay. So the 2 ways that this can run should throw you for a little bit of a loop. This way, we do not print line 5, but we do print line 4. It's out of order. So we actually run line 3A. When we run return, then we go to the finally, and then we return. Okay, so we have try catch, catch, and then we can add a finally to any of those. This is often used in dealing with text files when we have to close a resource. Whether or not we successfully read from a file, we got to close that file so that other things can have access to it. And this is kind of why we had to do the exception handling part of this before we talked about files. So you got away this week without any homework, so I'll have to make it really miserable next week for you.